Good morning. I want to welcome you to MITRE Institute Distinguished Lecture Series. This morning we have a particular treat in mind. I don't know, several of you may have already been prepared for this talk if you saw several months ago in the National Geographic a beautiful color display of some new discoveries near the Great Pyramid in Egypt. But today our speaker is Professor Farouk El-Baz, who is the founding director of an interdisciplinary center at Boston University for remote sensing. He has had a very interesting career and experience in a variety of areas, ranging from studies of the arid desert lands in Egypt to the arid lands on the moon. Professor El-Baz is the author and co-editor of a number of books. His technical specialty started off as geology, but he worked on the NASA program involved in the selection of the Apollo lunar landing site. As I said, he has worked in Egypt studying the arid lands, and there has done some very interesting work using technologies of interest to us, that is satellite-based radar systems. He has worked more recently, and what we're going to hear about today, studies involving remote evaluations of archaeological finds in a way that will still preserve those finds without damage to the atmosphere. But I think most interesting is the fact that Professor El-Baz has done a series of studies in which he has applied new, modern, high technology to the very old science of archaeology. And it indeed is a great pleasure for us to have Professor El-Baz here today. And without further comment, I'll let him speak to you about some of the interesting things that he's been doing. Professor El-Baz.
Thank you very much, Mr. Cunningham. Ladies and gentlemen, my objective this morning is to exemplify to you one of the uses of the high technology of remote sensing in archaeological investigation. Many of you, and I see many friendly faces from people that worked with me in the past, many of you know what remote sensing is, and for those who do not, remote sensing can be applied to all the investigations of something from afar, or having to study something without touching it. So it includes looking at the Earth or the ocean from space altitudes. It also includes geophysical investigations like seismic investigations and so on, and also includes, perhaps, if you go to a doctor and he looks at your chest with an X-ray machine, he's actually using a remote sensing technique. He is studying the bone structure and the lungs without touching them or seeing this from afar. At the Center for Remote Sensing at Boston University, we're applying remote sensing with this widest application, and at least as the definition goes. And therefore, we are beginning now to apply remote sensing technologies and methodologies to archaeology. When you think of archaeologists and archaeological investigations, you think of a small area that needs to be studied in detail. So a photograph taken from space may not have enough resolution or detail so that you can get something out of it. But you can do that from aerial photographs, and you can do that also from images taken from balloons or tethered blimps, and we have this kind of thing. In addition, if we can include in the term remote sensing geophysical investigations looking at the ground with magnetometers, gravimeters, and ground penetrating radars that go through the earth and are reflected back and give you a radar reflection so that you can interpret the subsurface layering, then you can apply remote sensing technology to archaeology. And the case that I would like to exemplify is one in Egypt. That story of it really started in about some 37 years ago, as King Farouk had a visitor from Saudi Arabia, and he took this visitor in his red car to show him the sights, and he took him first to the pyramids, very much like any tourist today. And the king could not drive all the way around the Great Pyramid because there was a huge pile of rock that had covered the southern side of the Great Pyramid up to some 60 feet high. A pile of rock that had fallen from the side of the pyramid and accumulated sand and rubble did not allow for passage of vehicles around that side of the pyramid. The king was rather disgusted at the Antiquities Service, and he called the director in, and he told them, "I'd like you to remove that pile of rocks." So it took the Antiquities Service 2 years to remove this because they had to do it very carefully in case there are important artifacts in that pile. And by the time they came down to the very bottom of that pile, as they cleared the rubble and the sand, they saw some blocks that are hewn in the rock, in the base of the mountain itself, or the plateau. So they recognize that there is something in here that is buried under some of these blocks, because the blocks are geometrically formed. They are not part of the natural rock formation. Very carefully, they removed one of them, and that was in May 26, 1954. And what they found beneath the block that was open was a huge chamber, about 100 feet long, that had a disassembled boat in it. They took out the boat, and they built a museum for it, and it is the oldest boat in existence, 4,500 years ago. And the whole story made an international stir, and the boat was, the museum for the boat was opened in 1982. It took them that long to put the boat together. And from the exhibition of the boat for just 5 or 7 years, some of the wood inside the boat started deteriorating. It may be because of the environmental condition. Inside may not be proper. So at the time of the discovery of that chamber, they recognized that there are actually 2 of them, because there were 2 sets of blocks, 40 in number each, at the axis of the Great Pyramid. Because they had so much trouble trying to put that boat together, they did not touch the second chamber. And it is because of the deterioration of the wood inside the museum that the Egyptian Antiquities Organization came to me about 3 years ago and asked whether there are all kinds of black boxes that we have here with working with the NASA programs and the space program in general that can measure the environmental parameters inside that second chamber without affecting it, so that we can figure out what to do for the environment inside the boat museum. And that's how the story began. We thought about this in terms of a scientific mission, very much like a mission to the moon. And rather than going up or going down, we have to learn everything there is to know about that chamber without affecting its environment whatsoever. So we made a science council and started thinking about it in terms of what is it that we need to do. And we recognize that we need to figure out exactly the shape of that chamber, its size and so on, figure out a profile of its contents, try to drill through the upper cover without affecting either the rock or the contents or the air inside, without heating the air, try to sample the air inside in case some of that air is ancient, and if it is hermetically sealed, measure the temperature, pressure, and humidity percent inside, take photographs of the contents, remove everything out, and seal it as if nothing happened. And that's really the story of this investigation right here, and this is what we will try to cover for you today. If we have the first slide, please. And we can dim the lights because I don't need them here. So what we're looking at here is a view, an aerial view, of the Great Pyramid on the right. These are the 3 pyramids, the main pyramids in the Giza Plateau. And just south, just off the shadow of the Great Pyramid, is the boat museum right here, which was erected on the site of discovery. Next. And if you look at on the side of the Great Pyramid, this is it. And this is the boat museum. And remember the pile of rock was like here at covering the chamber in which the first boat was discovered, this assembled boat. And this is the boat as it is now housed in the boat museum in Giza, a very beautiful boat with a couple of cabins. The largest one is supposed to have been for Pharaoh, and the one for a shed for the captain of the ship. And as you see, there is quite a bit of glass in the museum for the boat, so maybe that has something to do with the preservation of the wood itself. And this is the way the wood was placed inside the first chamber. You can see the wood planks there, and all the white pieces are pieces of the mortar that had fallen from the top, from between the block that covered that pit. The ancient Egyptian engineers had put the pieces of wood that belonged to the same side of the boat together, and they tied it with rope. And they actually had made little marks on the sides of the wood that would fit together, for instance with a scarab or a snake or something like that on either side, so that you would know where they would fit together. Very much like when you go and buy something from Sears and it would tell you put point A to point B and squeeze it and this and exactly almost the same way. Even though, with that in mind, it took the Egyptian Antiquities Conservator some 15 years to put the boat together, because they built models and then they thought they figured it out, and then they tried to put the boat together. Almost after they finished 3/4 of it, they figured out that they were doing it all wrong, and they had to take it apart again and try one more time. That was the work of this gentleman right here, Haj Ahmed Yusuf Mustafa, who is the conservator that put the boat together. And he certainly did a fantastic job, because of the fact that some of the curvature, or most of the curvature, in the wood planks had been lost. And therefore, most of the wood now that by the time they had found it, was absolutely straight and flat. But it wasn't when the boat was made, it was curved. But how much curvature would you have in each and every piece? So he had to figure all of this out. Now, with the situation as it is today, when the conservator put all of the planks for the cabin, the main cabin on the boat, there were no spaces between these pieces of wood. And today you can see very clearly there's all kinds of spaces, which means that some of that wood had shrunk considerably. And this is the major part of the deterioration. Supposedly, the boat was in length was something like 144 feet after it was assembled, and now it has shrunk by some 20 inches, although the measurements were not made by the same person and we're not really certain, but there are indications that the shrinkage had been, for the overall length of the boat, had been over 1 foot. Now the situation was as follows. If we're looking at the bottom right here is a plan of the Great Pyramid itself, and if you take the axis of the Great Pyramid, there were 40 blocks just east of the Great Pyramid. We're now looking south, and 40 blocks west of that axis. The ancient Egyptians were very geometrical, and they did things in exact positions like that. And this was the group of blocks that had been removed to uncover the first boat, and this one was the one that had not been touched, which is the object of this investigation that we did as a joint research project between the Egyptian Antiquities Organization and the National Geographic Society. The way the ancient Egyptians did this, it is in a plain view. First, here is the